So the fifth question in lead code is to find the longest palindromic substring. So what does that mean is, so we'll be given a string here, okay, but we'll have to find out the substring of it, and the condition is it should be a palindromic. So palindromic meaning like if you read it from left to right or right to left, it should be the same. Basically, BAB here, right? It's the same like if you read it from left or right, okay. So now how to approach this problem, right? There are multiple ways, like I mean one is to just do the brute force, and also we can do the dynamic approach, actually dynamic programming approach. I'll just brief you about the approaches I used here, okay. So the first thing is iterative approach. So basically what we'll be doing is we'll be trying out all the combinations, right? So nothing but it's like a n square combinations, right? So be like I mean all the combinations we'll be trying out here, and we'll be checking if that is a palindrome or not, okay. That is one of the approach. But to improve some time complexity, what we can do is we can, instead of like as we want a maximum string, right, maximum length string, what we can do is we can start from the end. Like we can pick this full string first, okay, and then check if this is a palindrome or not. If this is itself is a palindrome, we don't need to proceed further, right? This is itself is a maximum length, correct? So what we'll do is we'll put the pointer in the start and we'll put the pointer in the to the end. We'll check if this is a palindrome or not. If it is not, then come to one reduce the end point and check if this is a palindrome or not, okay. And if it is a palindrome, then don't compare the less than that, okay. That's how like it will improve some time, like time complexity there, okay. That's where here actually. So if you find, and also let's say that in our first iteration, right, like first iteration can be like our start pointer will be here, okay, BABAD and BABABAB, okay. This is our iteration. In the second iteration, maybe it will start from here, correct, ABAD, correct. And let's say that in the last iteration itself we found a substring of length 4, okay. And we don't need to necessarily check for the any character, any string which is less than length 4, right? So that is the condition here. We need to restrict, like if it is always the start and maximum, like whatever the window we consider, right, we should be greater than or equal to the max length of the max length, okay. So that is the thing, like we'll start from the big ending, and so that we'll say we can save some time complexity. And the next thing is, before actually trying out this reversing and doing the palindrome check, right, first let's check that if the first and the last character is same or not. If it is same, then we can proceed further. If it is not same, then we can just continue, like we can just ignore it, and we don't need to reverse it and do the comparison here. That's not a required thing, okay. This is the iterative approach, and I think it was like 42% of the was the thing. One second. It was like I mean this is, I think that this is a dynamic programming one. Let me just rerun it quickly. So as I have, let me this submit. This is accepted solution, but yeah, this is a 43%. It is faster than only 43%. And also I've tried the dynamic approach as well. So I didn't find any much of improvement. Actually, I see a deterioration here, but I've just shared how it works actually here. Okay. So if I run this, the performance is actually like comparatively it is kind of deteriorated, but we'll see. Like I mean I will just explain the method that is being used here, okay. So how we can use the dynamic programming here, right? So basically when it comes to dynamic programming, what is it about, right? Like dynamic programming is basically like splitting down the biggest problem into small pieces, and solving all those small pieces and making use like during the big competition, right? Like whenever we want to do any competition, we will be making use of already computed things, okay. That will improve the time complexity here. So how does the dynamic programming will help here, correct? So now what we'll have to do is, let's say that we'll have to in a brute force or in any way, right, we don't have a choice to leave out any combinations. So basically we'll have to try out the combinations here such that, let's say that I am picking some things, right, some combination, and I have to check that there is a palindrome or not, correct? Now let's say that I am going to pick this string, B A. Let's say that I will pick from here to here. Okay, sorry, I will pick from here to, okay, I already highlighted. So I will pick from here to here. Okay, and now I check that I want to check this is a palindrome or not. What I will do, I will have a start pointer and I will have a end pointer here. Okay, so this, okay, start is equal to end, so might be a palindrome. Next thing what I will do is I will increase the start pointer here and I will decrease the end point here. I will do the check again. Okay, this is also same, and it could be a palindrome, and again I will go deeper into it, correct? And now it's a small string, so we just got the answer in within like 3 steps. But if it's the length of the string is more, it will be like doing the same calculations again and again, correct? Next time, okay, this time I have done this, okay, in this iteration. Maybe in some other iteration I might have already done this calculation, correct? A is a palindrome, that I know. Like, I mean, I might have already done this computation and I could save it at somewhere, correct? So that it will be of helpful when I am doing the calculation for this range, right? If I, when I am doing the computation for this, I could use this calculation, right? That's how the dynamic programming will come into picture here. And when I am doing this calculation, I can make use of this computation. Let's say that if I had saved somewhere that B is also a palindromic, I can use it, right? That's what this dynamic programming approach is about. So what we will do now is we will say that individual, firstly we'll start with single characters and then we'll go to the two characters. Similarly, we will increase the length. So what I mean is, let's say that in the first way, we will say, like, we know that individual characters are nothing but a palindromic, correct? However, if we read it from left or right, it doesn't matter, all are palindromics, right? So we'll store this result in one table, right? Like, I mean, it's nothing but a now, because okay, like white table, right? Like, before going to that, let's say that if I want, okay, now we have said that single characters are palindromic, right? Now let's go for the second one. Let's say that I want to store this result also, ba and ba and ad. These are the combinations, correct? I want to store this also. Like, this is a range, right? I have to, from where to where we are considering the length of a string. So to store this information, we need a 2D data, right? That is nothing but a table, right? We'll need a table here, and it will be like 0 comma 0 0 comma 1. Like, I mean, it is from 0 1 2 3, right? We'll be storing that length here. 0 comma 0 is nothing but, will be, this is a one character data, right? What we'll initially do is, like, as I said, we'll be taking the one character's analysis, correct? We'll do the analysis on one single character. So we'll pick one character and we'll say, like, if it is a, like, obviously we know that it's a palindrome, so we'll say we'll update our 2D table wherever I is equal to j, right? We'll set it as true, meaning that's a palindrome. Then what we'll do is we'll pick the two characters, and then two characters, when will be it be palindromic? When both are same, right? At that time it will be palindromic. So what we'll do is, if I and start is equal to end, right? If the characters are same, then we'll say that is a palindromic, else it is a false. Okay, now what we can do is, when we are going to do the analysis for the third character, so let's say that for this, right, a b and a. Okay, like during our first analysis, we have stored the result for all these characters in a 2D table, and also during our analysis, we have stored the result for these two. Correct. AB also we have stored, and BI is also stored. So when I am doing the validation for third one, I can reuse it, right? So that's why, similarly, we cannot like, I mean, go one by one, right? One, two, three. So we can, what we can do is, we have done initial analysis that for the length one and length two we have stored the result. We'll start, like, I mean, we'll do the remaining approach in the for loop next. Okay, so just to give the overview, right? So what we'll do now is, if you show that, if you show the same thing in a programmatic way, so let's say that this is our example, and we'll say that none of them are none of them are palindromic. Okay, and for the length one, we'll say wherever I comma uh, like, I mean, wherever it is 0 comma 0 1 comma 1 2 comma 2, right? Those are true. These are like a length one, meaning for a single character it's a palindromic. And for similarly for length 2, again, we should be like, the current character and the next character should be the same, right? A b b c c, these kind of are palindromic, so we'll be setting the same, we'll be updating this table basically, right? And now we'll have to do for the remaining length. Let's say that here, right, how many characters I have? B 6 characters I have, correct? If 6 characters I have, I need to prepare the six strings, basically, like I mean characters of the strings, right? Like I need to, now we have done the validation for 1 and 2, we still have to do for 3 4 5 6. That will be handled here. Okay, and now we need to prepare strings, correct? We have to try the different combinations of string, right? If you just do this, like this will give us a length. Okay, and now we will be setting the window, like I mean just to make sure that we don't run out of that available characters, right? We need to make sure that we don't let's say that we are here, right? Three characters, BAB and ABB and BBA and BAD is the last. I should not go for AD and something extra, right? So we need to make sure that we label our ranges correctly as this. Total number of characters, mine what is the range of our what is the length of the substring that we are looking at? Okay, n minus 3. So it will be like 6, right? 6 minus 3 is equal to 3. But as we are using a range, it should be plus 1 actually. So the or else it would be ignored, right? If your range of 3 is nothing but 0 1 2, so range of 4 is nothing but 0 1 2 3, right? We'll need this one extra value here. Okay, so now if you do the just analyze, right? If you see the combinations of strings, we'll get to see like this actually. So nothing but for a 3 characters we are making this combination BAB, ABB, BBA, BAD, right? So now what will happen internally is, okay, now for a, let's say that for we are checking if the we are looking for a substring of length 3. Okay, we got a combination, but we now will have to check if it is a palindrome or not, correct? So what we'll do is we will check if the first character and the last characters is same or not here. S of I is equal to S of J. Okay, if it is same, then only we'll go to the next. If it is not same, then no necessary of checking it, right? Let's say that it is a ABC, correct? A and C are not equal, obviously. So it is true that like it won't be a palindromic, correct? So we don't go to the next thing. So now let's say that it is a ABA, right? ABBA. Okay, let's say that ABBA. Okay, and now A and A, like I mean the first character and last character are the same. And then what we can do is we can use the pre-computed results here. So when I'm doing the calculation for the 3, right, ABA, and I can make use of the two computations I have done, correct? Let's say that AB here, right? Sorry, when I'm doing the calculation for length 3, I can use the calculations that I've done for 1 and 2, correct? Similarly, when I go to the validation for 4, I can use the validation that I have already done it for 3 in this iteration. So that's how it is working. So we are making reusing the calculation that was done for the previous from the previous iteration here, right? So we'll be checking if that is equal or not, and also we'll read the value, like I mean if the old value is true or false. Based on that, we will set the true, like I mean finally, like I mean we will be updating that string. Let's say that if I will pick any, this is right, let's say that during this iteration we'll pick this, and we'll see if this is a palindromic or not, and then yeah, this is a palindromic, so we'll update it as it to true. Yeah, this is what is happening here. So yeah, so yeah, like I mean the, at least from my end, like what I'm observing is with this approach, I don't see the performance improvement either, but I'm not sure if I'm missing something here. But I saw some better results here, not so good, but yeah, saw a better result with this approach actually. Yeah, thank you.